Hello, folks. Yeah, that'll do. Cool. We are back. I am going to do a whole ton of streaming this week. Had a few days working on some other stuff. Got some cool results, actually. But yeah, we're going to just be working on all sorts of things. Oops. 1 second. Let me read one message and we will go. All right. Let me switch the screen over. Hey, Jess. Get rid of X. We don't need this garbage anymore. Uh-oh. Are we using our right microphone? Yeah, we better be, right? Yeah, cool. We got the good mic. Close all this crap. And welcome, Carlos. Chess and self-play, amazing results. Ooh. Cool. I'm looking forward to this, yeah. And working with Spencer will be really good for you as well, Jess. So, on the end side, Spencer is probably about as good as I am at this point on the M side, at least. There's still some research stuff. He's still learning, but like Spencer's very, very good. You'll be able to learn a lot if you're doing work with him. Hey, FBR, welcome. Out dash B. Cool. So the plan for today is min grew. Let me go grab the repo for this. Welcome, Julian. Oh, and Cal invite as well. Let me double check. I got all these messages from like the last several days that I just haven't been Why? Something's wrong with my stupid browser. It's not letting me make a new window. Docket, I will show you. It's min grew. For some reason, yeah, let's close all this. Oh, there it is. I just have to make sure nobody's stuck random crap on my calendar. And we're gonna start on min grew. Cool. Yeah, this meeting is Friday. Good. Alright, so this is min grew. pretty simple drop-in, it looks like. Doesn't depend on anything. Takes a sequence. Cool. See if we can just adapt this in to Puffer real quick. Hello, Peru. Dim, expansion factor. Okay, so this takes returns next. Return next prev hidden. Wait. Let me see the sample code for this. There's something a little weird with it. Yeah, so you want both. Return. We can just get rid of this. Take a look at... Oh, were you the one who sent me, like, the really cool threading stuff? I'm sorry, I've had just, like, a billion things. I do mean to get to this. This is just... When somebody sends me, like, a big PR like this... I mean, okay, this is not big in terms of lines, but, like... Let me see. Let me read through this now on stream, at least. Set backend multi-threading. CPU deep, but not GPU wide. Okay. Oh, too many threads. Wait, when you say too many threads, why? Hmm. SRAND is not thread safe. Yeah. Let me see roughly what this is. I am going to use this Peru. Like, we are going to have native multi-threading at some point here. And I'm definitely going to use your thing. Let me see how big this is. Okay, so C thread step. Like, I haven't even done threading in C. Well, I haven't done thread-based stuff, like, ever, honestly, because you never do it in Python, because Python's threading doesn't work. So all my, like, distributed stuff has been multi-process based. So I actually have to go read up on, like, all the gotchas for thread safety. Not a ton of code, at least. Welcome, SPY. A lot of complexity. Yo, Peru, you want to do me a favor? If you want to get this into like a real project where people will appreciate your work a ton, if this helps, can you see if it works on Drive? If you already have, like, your branch set up? If it works on Puffer Drive and gives speed up there, like, you'll get those folks really excited. That's an env where there's a lot of, like, it's one of the slower envs, and it's one of the ones that's being very widely used. The NYU lab and a couple companies. I see. Yeah, go check on that, and I will set aside some time to, like, actually get into this. I mean, you can tell here it's going to take me, like, this is not something I can just, like, play around with a little bit and merge, like, right away, right? Like, I'm actually gonna have to go do quite a bit of looking into this and such. Good projects for job software. Don't ask me for job stuff, man. This is not the place to go to for, like, standard traditional job path. Pop in your radar, libs. Yeah, so libtorch. I have the libtorch trainer working now, Peru. Let me go see if I missed, like, anything major. I'll show you what my DMs look like so you can see what a freaking mess it is. 20K account. Hey, this is my freaking DMs. Like, it's mostly just spam. Torch pin. Okay, yeah, so pin is good. If you can get pin speed ups out of pin, that actually would be huge. Pin plus NB is placed lower. Not that helpful. Pin plus an NB. What's NB? The thing is, I don't know if you can have pin shared memory, right? Like, I think if you have thread-based stuff, then you can do... I think you can have pinned mem that is available across threads. I don't know. You also have to, like, not have locks on it, right? Because, like, you're writing to the same memory, but you're writing to different locations, and you can guarantee that you're never going to have race conditions on it. So it's kind of fiddly. Yeah. The C thread stuff is exciting, though, because we are moving more stuff lower level over time. It's tricky because it's like I'm kind of walking this tightrope of this stuff has to be accessible, but like at the same time, literally the Python versions of a lot of these things are more complex than the C counterparts. And it's not even like they're only more accessible in the sense that, oh, Python, that's familiar. But like if you're actually willing to do this thing the way it's supposed to be done, it's actually simpler a lot of the way we're doing things. All right. Let me do some mingru today, though. While you look at that. So mingru here. So this is batch T. It's only a little bit faster right now, Carlos. There's a lot more stuff to be done here. So essentially, if I can get mingru to work, then I can also get BF16 to work. Because the LSTM has like a specific QDNN kernel that is doesn't have good BF16. But then this I should just be able to do whatever with. We're just gonna like copy paste this and fix it for now. And The C++ is easier to read. Oh, okay. So there's not feature parity yet, though, Carlos, because the forward pass in that, it's basically like all the fancy optimizations that we have for async are not there on the C++ at the moment. I would expect that they're going to end up being about the same complexity, is what I will say. Unless we figure out that we can just do everything on GPU, but I kind of doubt that. I need to actually do some more research on this. Like, I need to learn more systems, man. I need to learn more systems. I'm not a systems background like dev, right? My background's AI and research. I just keep doing more and more systems-y stuff over time. Hey, welcome, Yaxine. How's it going? Yo, you've been asking a lot of stuff lately that is literally on the docket for right now, actually. Like the whole precision thing and perf and LSTM. Like, this is all what I'm doing this week. Oh, also, you asked about libtorch. Here, I'll show you. Yassine? With a Yassine, alright. That's how we pronounce it. Where did that come from, anyways? That's funny. Where is it? Where is it? Where is it? Why did I just open X automatically? I should have opened Puffer. Here, I'll show you where the libtorch is. It's obviously work in progress. But we've got the whole policy set up in libtorch. We've got, what's this, forward train. We've got our annealing. We've got the evaluate function here. We've got step, this is in testing, and then we've got train. And it's tested numerically to match. So this matches exactly with the Python version as well. There's still some stuff that I need to do with this. But what I do next with this is depending on the mingru stuff, which is right now me trying to optimize the LSTM cell and make it be BF16 compatible. Hey, Will. Better do in C. The C is really easy. Yeah, the C is really easy. I wrote a kernel for collaborators over the weekend, and like their entire training is now 3x faster. And like I was fighting with like, do I do it in Triton? Do I do it in Cutlass? Yada yada yada. It just ended up being vanilla, just CUDA, and way simpler. Though the CUDA rabbit hole's a little deeper than that, unfortunately. Where's gonna take it? Glad you're going. Yeah, man, like leave this stuff to me. You're not gonna have a fun time with this. Like I believe, like the Eng stuff, you can absolutely get to work. But stuff with like, for instance, here, some of the logic right now is, so the LSTM has a like private, probably not open source cuDNN kernel that doesn't play nice with BF16. It also is not good for parallelism. You can get around that with really big mini batches. It's a limitation, but not a huge one. I want stuff to work for all mini batch sizes, though, and I also don't want to have this separate forward evaluate like cell and sequence model. So switching to something else would accomplish that. There are a few candidates. Probably MinGru is like the most likely one. Any variant of transformer is probably going to be slower. Mamba, maybe. MinGru is probably the best one of these, but now what I have to do is I implement it first in Python. I see whether I can get it to do the same training result on a few different M's as our default LSTMs once I parameter match and sweep everything. And then if that's the case, right, then I run a more full set of experiments on more of our M's. I see if we can like get same perf on neural MMO. And if I can do all that, then it's going to be worth putting into the C version, right? And then from there, like, I could actually get a kernel optimized for this thing and make it even faster. Like, there are many, many layers to this shit. But then, like, I'm also at the same time balancing this in my head with, like, the likelihood that this thing turns out to actually be any good based on my understanding of how often I know that even widely cited published research just turns out to be bad, right? So that's a little peek behind the curtain for you. Long time to make sure it's stable. Yeah, so that's what I do, right? That's what I do on core puffer. And then you just get to use it pretty much. And obviously it's hackable, right? All the stuff I make is going to be super hackable. But like the stuff that's kind of gated behind these really larger research questions is kind of better to just let me figure it out. Like you can do it, it's just going to take a ton of time. Like there's specific tasks I farm out to people in the community sometimes because I only have so much energy. But typically, time efficiency wise, I'm going to be much quicker on a lot of these things. Yeah, this thing needs to have. Only thing I patched in my vendor PufferLib is how things get moved. When I don't need CPU buffer, env is on GPU. Yeah, things get a lot easier when the env is on GPU. We actually do have GPU env prototypes now as well. And I think that there might be a way to make it so I can run the exact same code, like compile the same code for CUDA and for C. So we might be doing that. That's like a 50-50 toss-up, whether I end up doing that for 4.0 or not. There are a few other things I want to build in as well. Total env will only go faster total if I parallelize more. Yeah, so that's the rough thing with GPU M's. A lot of the time, you just need tons and tons of cores, which is annoying. Oh yeah, if you want to do the CPU implementation, you can try Peru's CPU multi-threading. That actually might be good for you. Though typically, I don't think you're running fast enough for that to be the bottleneck yet. Right? Typically, we only see bottlenecks there when we're at millions of steps per second per GPU. Like every time you optimize 10x, you have to redo everything. It's a pain. Cocos. What is that? Hmm. I mean, interesting, but I kind of don't want anything... Unless this is, like, really good, I kind of don't want anything more between me and the hardware, right? Like, if possible, I kind of want my stack to just be... Like, I will be very happy if I can have my stack just be less and less Python over time, and then just C and CUDA. That's all I want. Yeah, don't ever ask an LLM to write you a kernel. It'll just like, oh, you can't ever just write CUDA. That's insane. You have to write Triton and Hooken, you know, or like output a Cutlass kernel or output what the fuck, what other things does it have? Oh yeah, CuPyX or whatever. It gives you a million like intermediates. Well, just like write the fucking kernel. It gives you this impression that things are way more complicated than they are. So the only thing that's actually legitimately complicated that I'd really like to know how to do here is cuBLAS is an open source. So like I can't go copy paste NVIDIA's linear kernel or matmul and then mess with it. Like it's actually really obnoxious when you want to do stuff that requires modifying core operations because they're not open source. I haven't found a good way around that yet. Yeah, Carlos, that is kind of nice. That's funny. Am I working on right now Mingru? We're gonna see if this alternative recurrent cell is any good. Coding bootcamp, that's how I landed here. Well, you'd be surprised. So the cool thing with this this setup here is there's state-of-the-art RL research, but there's also stuff that's pretty accessible to hobbyists and relatively new programmers. Like if you check all these demos on the website, like many of these are written by contributors. Some of them came in without much experience. Like a relatively new programmer can totally write something like this, and you get some exposure to RL, you get some exposure to science and research. It's a fun way to learn stuff and contribute to science. Nope, I am absolute crap at LeetCode. LeetCode is a good way to get a job and a bad way to do just about anything else. As a result, I've never bothered with it. Can you stop auto-completing, please? That's good. You already have a job? I've never done... Okay, I guess I technically had to pass a few very easy screens for stupid internships, but like I've never done a job in which I've had to go through like that type of interview, right? Like OpenAI used to not do that even with the internships then. I had like a couple internships that they did a few things. But like I've never done that type of a thing. I do produce a lot of really cool projects that have some sophisticated engineering behind them though. Thankful for you making RL more accessible. It's going to end up being, I think, the biggest hobby area of AI because you can just do indie game dev. Like you can do low-level game programming and then also train bots to play your game or to be enemies or whatever. So I think actually RL is going to have like RL is going to be the accessible area of AI, which is kind of ironic because RL is infrastructure-wise by far the hardest. And it's not even close. Leak code hard for Square. Yeah. I don't think I can do most of the easies, like, honestly. It just doesn't matter. It just does not matter at all. Daniel Suarez. Hello, Suarez. What do you recommend for new programmers? I have a guide for that as well. My two probably best pieces of educational content. They're on my articles tab. There's my RL guide and there's my programming and ML guide. So there you go. That's my best advice in one place. Rote practice, very gameable. Yes, it's gameable. Quick at writing SQL queries. I mean, it isn't basic life check. Yeah. Really the only way to tell if somebody is good is to review substantial portions of their code. And then ask them about stuff. Before LLMs, you couldn't fake that. Now you can kind of fake it. You can't fake it just by, like, asking the LLM to write stuff for you. That'll still be a disaster. You at least have to be kind of smart to fake stuff. But, like, you can't fake actually being effective at building impressive stuff. Yeah, the OpenAI interviews were the best. I think the best done I'd ever had, which were you would just go give a research talk open to the whole company, have to answer questions, and then you'd chat with like 3 or 4 of their engineers for an hour apiece about research and about, projects that you've worked on, stuff they're working on, like where stuff might fit. Yeah. Objective but uninformative is not helpful. And like ultimately it is a very biased process. Like for instance, there are people who write code in a way that's completely anathema to me, who have built good stuff, right? But like I could never work with them. They would make it impossible for me to get anything done just by virtue of the way they structure all their stuff. So there is actually an element of compatibility to it. Got into RL not for Puffer. Tried with SB3 is such a joke. Yeah. Well, this is what I'm trying to do partially, right? I mean, it was kind of like a happy accident, if I'm going to be honest with you, that Puffer ended up making everything this accessible. But like once I saw it working, I was like, okay, awesome. You know, if I can advance cutting edge research and make this a super accessible area where there are going to be tons of people working on cool little projects, that's great. That's great. Oh, you dummy. What are you doing right now? I am currently testing or integrating MinGrew to Puffer, and the goal is to see if we can get this thing to match performance when you parameter match it with an LSTM. And if I can do that across a bunch of ends, then this thing is going to be a huge speed up for Puffer. So, little bit of integration, bunch of experiments, and the goal is pure speed out of this thing. I do not need this to be asymptotically better whatsoever. I just need it to be faster. What is this? Ooh, okay, cool. Somebody has a kernel for this. Yeah, Lucid Reigns has all the implementations. How's your time at OpenAI? Best place I've worked. By a mile. Very different place from what it is now, mind you. But back then it was awesome. Andre was not there. I've never worked with him personally. I've chatted with him a bunch when he was a PhD student when I was interning and at Stanford. Ilya, yes, I didn't work with him directly, but you know, I had lots of conversations with him. He's pretty awesome as well. Yeah, I really have nothing bad to say about Ilya. Great guy. Visionary. Um, really, really unique way of communicating research. Very effective guy. Alec was there as well. Alec was great. Mm-hmm. Dolman as well. I'd like to think I had some pretty insightful additions while I was there as well. At least some of the things I told them turned out to be true a few years later. If I go back, not as it is today. They're not doing any of this stuff anymore, man. They do language models. I know what I just did. They just do... Yeah, but it's okay. I don't... Like, Yasin, I don't need, I really don't need a ton of resources to make this work. Like, RL will just be set within a year or two. If I just keep doing what I'm doing now, RL will be well taken care of. That's kind of the awesome thing about this, right? Probably the biggest one, Jess, was I told them that the emergent tool use transfer experiments, which were originally one of the main purposes of that project, I told them that those really weren't going to work very well at all, and that you're not going to get transfer by training on one task, and then getting and then like fine tuning on others like sort of high level related tasks. You're only going to get transfer via like wide distributions of domain randomization or task conditional or something like that, which is then what XLAN did much more effectively several years later. So I pretty much told them exactly how and why one of their larger projects was not going to work, and it happened in the exact way that I told them. So I guess it's not a contribution if they don't frickin' listen, but not much I can do about that. How much did it cost? I don't know who got him anyways. That's somebody who I've like lost all respect for though, based on me attempting to work with like various bits of his papers. Like the whole narrative set by the Dreamer line is just false. A lot of it, actually, like more than that. Which is unfortunate because if the Dreamer papers actually worked the way that it's written on paper, or like they work in the way that they're presented, it would be probably my favorite line of work, and I'd be completely changing the way I was doing a lot of my own stuff. But they just don't. What the heck is wrong with log values? Huh? Oh. It's inefficient, capital intensive. What is? Not interested in language models? Not really, Spirit. There are plenty of people to go do language modeling now. There's nobody to do RL. So I'm gonna do I'm gonna do the thing that only I can do. I'll link him the repro every day. Wait, what? Wait, why pre-training took some interest? Inherently capital intensive. Yeah, that makes sense. Can you build off previous iterations? Or you gotta start... What, my stuff? So my stuff you can technically build off previous iterations, but it's so fast that we don't bother. Right? If I can train a new model from scratch in 30 seconds... Yeah, Carpathy is right. Like, the way RL's being used on language models right now is really dumb. Doesn't apply to the stuff I'm doing, though. Like, look, technically, if you wait around long enough, right? Like, the language models will... Like, there will eventually be a time where you can just run, like, big language models on a chip. Like, one chip at home, very cheap. And, like, that will change the calculus a bunch. But, like, I'm not waiting 2 decades for that to happen. Or even 1 decade, right? Like, I'm gonna have RL working well before then. And even when, like, the chips do get that powerful, that just means that we're gonna be able to run, like, exabytes of simulations on one chip. That actually would be a fun project. Try to run first RL experiment to use an exabyte of simulated data. I don't think it's been done before. I think we're still a couple orders of magnitudes off of it being reasonable, though. Integer puffer. Oh, well, he has open source code, dude. It's just really bad and it's really brittle. And, like, most of the things in the paper, you can just run ablations on them, and they don't hold up. So, like, there's a huge difference between you got the results that you wrote in the paper, and the thing works in the way that you describe it, right? It's presented as this, like, super robust general thing, and it's just, like, really shitty and brittle. And it's actually very difficult to even... Like, it's very difficult to replicate this stuff as well. The tiny RNet, like the tiny recursive nets paper, like that sounds interesting, but I haven't really seen anything about it yet, you know? Like, I haven't actually gone and looked. Why is this hidden shape this, like, why is this like this? Well, I'm not gonna go read the paper right now on stream, man. I'm working on this. I saw it on Twitter. Yeah, so that's what we're doing now. So if this actually works, this will actually make Puffer even simpler because we won't have to do, like, we won't have to do this really obnoxious cell plus, like, sequence model split thing. It'll just be one kernel. Farm Twitter approach is not legitimate citations. Oh, you think legitimate citations mean anything? I hate to break it to you. They're equally meaningless. At, like, some constant ratio. Yeah. You would not believe how unbelievably bullshit, like, academia it is. Like, if you just kind of model the world as, like, everything being middle school playground dynamics, and you just, like, assume everything is stupid until proven otherwise, you're going to be more right. You're going to be right more of the time than if you assume that the serious people must actually know what they're doing. It's kind of ridiculous. Both parents are academics. Yeah, I did not have that benefit. I had to figure this shit out on my own. Wait, why is it doing this? To hidden in gate dot chunk. So do we want this thing to be? Confused. Yeah, that is also true. That is also true. It's not all bad. Real models predict next observations. Like, train a model that predicts the next observations, and then you can do stuff like have the model hallucinate the future and train on it. The problem is training predictive models kind of hard and kind of slow. It's one of those things that just sounds unbelievably cool until you start thinking about it. And then it's still unbelievably cool. It's just like, no, nowhere near as practical. Can they be auto-regressive? Yeah, you train the world model like, you do train the world model that way, though you don't usually train it on sequences the same. No, you do pretty much train it the same way as a language model. But then you also have RL in the loop. I don't know. I wrote a blog post. It's like, why is it why RL failed to bootstrap? It mentions a couple things about that. Open world game age. What limitations? I wouldn't say that we're running into, like, what's preventing us from running this stuff on that? Well, it's two things, right? Um, we don't have enough ends that are like that we can use for research that are also fast. Like, my own neural MMO and a few other adjacent works are probably the only ones. There's some core algorithm challenges still, but then I guess it depends on, like, the horizons, right? Like, could I make like enemy AI and stuff, or like little, like, localized things that would run in an open world? Yeah, absolutely. It's also just demand, right? Like, um, if a big game company were to come to me tomorrow and say, "Hey, we really want this to work. We want to, like, support the research around this, and then we want to have, exclusive we want to have exclusive access to information on, like, how to get these into our game and stuff." Like, I could do that, but right now there is not the, like, usually industry doesn't have that sort of demand until the research is relatively close, and that's still, like, the type of thing that's probably going to be Puffer 5. Ego ruins academics. Guilty as charged there. Got an ego that can fill the room. But the thing is crazy is you actually kind of have to have a massive ego, because otherwise it's like you're kind of fighting the entirety of human ignorance in research. You kind of have to be a little nutty to assume that you're going to be able to figure something out that nobody else has. Multi-policy league, self-play, something on the roadmap. Test policy. Yeah, so Julian, people are working on self-play right now. Multi-policy league base, though, that is another story, because that's, like, the only source of that is AlphaStar, and I am not personally convinced that that is even a good implementation of that type of work. So we're starting with more the Dota-style fictitious self-play, and then we're going to see from there. Because, like, it's unclear whether League play is good. It is absolutely clear that it is woefully inefficient. So... why wouldn't you fork a RuneScape and run a simulation? So, UK, that is very close to my PhD. And what I would have to do is I would have to do that and then go line by line in that code, port it to C, and make it run 1,000 times faster. And that would be like, in terms of things that I would be super excited about, like that's at the top of the list, because that would be the best benchmark for RL, period. There are a bunch of other things that you can also do that are hard and more practical, but like that would be an amazing thing. And we have like a mini MMO on the website, which is Neural MMO 3, which gets a decent bit of the way there, but it doesn't have like, you know, quests and a lot of structure to the map and, you know, area-based progression and that sort of a thing. What if you got help for doing that? It would have to be very qualified help because it would be a big project and you can't make a mess of it. But then, yeah, that would be awesome. I wonder how much code that would be. I mean, I wouldn't be surprised if we could get... it would be bigger than any of the environments in Puffer right now, that's for sure. It's mostly just the huge amount of content, right? Hmm. Super crazy good def hop in. So if you're interested in this and serious, then what you would want to do first, so take a look at my work here. This is Neural MMO 3. So this guy, I'm playing it now, but it was the bot playing it before. You can run around. There's a market. You can buy stuff. You can sell stuff. You can fight enemies if I can find one that's not super over leveled. This one is probably going to kick my ass. Yeah, that one's going to kick my ass. I don't think you can kill a level 5 from level 1. Yeah, and then get one shot almost. Kind of hard game, but you can level up, and if I just hit, you know, take my hands off, hit control, now the agent is playing it. And these guys actually will get like level 8 or 10 most of the time. And they will equip armor, they'll buy stuff, they'll trade with each other. So there's a lot of complexity in here already. But obviously a full MMO is way bigger than this. If you check the code for this, one of the first C environments that I wrote, pretty much the whole code is just this file. Like 2.8K lines. A good like third of it is the rendering, maybe more. The rendering is kind of hard. But the rest of it's very simple C. The goal would be to keep probably this or higher code quality. So probably even simpler, like more like simpler, more straightforward than this. And then there are also a couple of research questions to answer on the representation of the game that we'd want to figure out as well for the next version. Oh, this is not solved yet, by the way. Like, probably a good thing to do would be to solve this environment fully first. This is only a third of the way solved. Like, it only gets to level, I think, 8 or 10 out of 25. Thousands of people willing to. You never get thousands of people willing to who are capable. There aren't thousands of, like, really good programmers just available to do stuff. Where you cannot admit you were wrong. Oh, so if you give me something where I'm, like, clearly unambiguously wrong, I will be the first to admit it. But the standard is just very high. The most recent of these was Muon, right? I thought optimizer research was a waste of time, and then Muon so did everything in on our project, so there you go. But if you give me something where it's like, you're maybe right, but I still think that I am, and you don't have proof, then I will fight you. on everything. You actually have to be very, very stubborn in research. Like, being open-minded is actually not a great trait a lot of the time in research. Because, like, you kind of just have to get, like, you get strong evidence for your approach. You're never going to be certain. People are going to get strong evidence for their approaches. They're not going to be certain. And then you just have to ignore those people and, like, keep digging at your thing until you know one way or the other and not get distracted. All right, what the hell happened with this? All right, some weird shit happened. Eh? What's missing from Neural MMO 3? Well, it's not a full MMO, right? It's like a procedural generated map with biomes that don't really do much. There's an elemental system that doesn't really do much. There are a couple weapons and there's some armor and levels, but like the maps don't really have structure. It's kind of unclear, right? Like how you would do a procedurally generated map that doesn't have or with like big chunks of structure. Like good PCG like that's actually pretty hard. Or if you wanted to do a fixed map like RuneScape is, then that's a lot of handwork. And then also, like, it's kind of annoying to do no PCG in RL. You just create all sorts of really screwy training dynamics that are not exactly the problem that you care about studying. Um, let's see. There's no like location-based progress, right? Like starting all the agents from one spot and then having them progress is kind of hard because like the agents just crowd each other out at the start. Like that type of thing is pretty difficult. There are a lot of challenges with getting this to a full scale. Somewhere I can read your thesis. You can. It's very long and boring. Because like a thesis is really just a whole bunch of papers stapled together. So what you can do is if you really want to, you can look here and you can get my thesis, which is some ungodly number, yeah, 170 pages. But if you want to just spend an hour and learn quite a bit, it's on YouTube. It's an hour. People enjoyed it a decent amount. And just Google this. Okay, so somehow this got unsqueezed. State got unsqueezed. Oh, I know. How does this work? Hello, welcome. I'm new here. Is this an environment optimization lib, or does PufferLib also provide algorithms? So PufferLib has fast ems, fast vectorization, novel and very good hyperparameter optimization, and one algorithm. It's not a reference library of a bunch of like existing algorithms. It's our current best algorithm, which at this point is PPO with some pretty substantial improvements that have been widely tested. You can train a lot of our baseline environments in like 30 seconds on one GPU. I'm trying to figure out how you're supposed to call this thing. Is this not supposed to be... Oh, the hidden dim is just wrong. That's fine, right? Thanks, we'll give it a try. Yep. There's the whole Discord, like, ton of people in there if you get stuck. I also stream a ton, so you can always ask on here. It's usually quite simple to get started, though. Hey, Convert. Loss. Oh. Why, hello there. That is interesting. Don't you think? It's not that bad for a first run. 40,000 parameter model. Okay, cool. This thing has some legs. We're not going to at least spend all day screwing with it to no effect. The model is too small. It needs to be parameter matched. There are a couple other things. I am exhausted. I got to get myself a cup of coffee and do a couple sets or something. Like, holy. Oh yeah, why do I have my camera like this as well? Hang on. Now let's get my full... Oh. Yeah, there we go. Much better. Join you for that? Couple sets. Alright, let me see. We'll do something hard. Could do some app training. Let's try dragon flags. Set of 8 of those. And then coffee. That is the hardest ab exercise I know. If anybody knows a better one, be my guest. But I think Bruce Lee knew what he was doing. Coffee and a cold drink. Chiefin? What does that mean? What on earth does that mean, my guy? Look at the pictures of the things I'm posting. That's funny. Okay, this is almost perfectly parameter matched with my original. Okay. Do I need to, like, totally resweep the hypers now? Solves Pong. 30k params. Mess with the learning rate a little bit. Did not help. So what do we do with this? We just launch a sweep? I guess that would be the smart thing to do, right? So tired. Let me see what this is supposed to be. So this is your linear. Lerp. Sigmoid. It's a pretty simple module, right? I guess we just sweep this version first. Oh, and this has the fast sweep stuff on it, doesn't it? Yeah, this does. Perfect. So I should just be able to, like... Okay, this is our Mingru. This not training is sketchy because this just trained on my other machine. Okay, there it goes. Oh, okay. Yeah, that's fine. And this guy can live over here for a bit. Go look at the Mingru paper. Did I say that you would be given a description? Oh, you stupid. Alright, so were R and N's all we needed? Okay, so here's Gru. Your GRU. It is a simpler model. You also have min LSTM. I suppose then we should test the stacked form next. Yeah, they're reporting they're 3-layer stacked. Where's table 3, my guy? I see table 2, I don't see table 3. Appendix? There is no table 3. Oh, there it is. I am dumb. But it does come, table 3 comes before table 2 in the text, so kinda silly. Okay, so they have this thing, where they say this thing does a pretty good. And I want to see if this is their 3-layer variant. Three layers. So apparently this thing is more meant to be stacked. Let's go take a look at our sweep so far, and then we will attempt a stacked version of this. Kind of funny, I never really tried to do a stacked version. Okay. So 450 is best so far. How do they stack this? Well, I can figure it out pretty easily now. I guess I never tried 2-layer LSTM, actually. That's kind of dumb in retrospect, right? Okay, let's do a simple 2-layer for now. Yeah. Time. Oh, and then you do we want to split it here or not? We probably don't want to split here, right? Yeah, we probably want to do it here. What made you want to try Mingru? The fact that we're doing like smaller batch size stuff with Constellation, and that LSTM also doesn't have a bfloat 16 kernel, so this can potentially kill two birds with one stone. Also, I have not chatted with you since. Congrats, Finn. Well, I guess that's a little pretentious to say. I think I should just say welcome. Yeah, we have some fun stuff to work on soon. Well, not that soon, but still. We have one layer Mingru sweeping right now. Not doing amazing yet. So we're gonna try stacking it. Yeah. I'll leave the announcements to Finn. Okay, I think this mostly works, right? God, so tired. This is awful. Oh, careful, Finn. It's still a contractor arrangement. But yeah, we're super excited. This is gonna be a lot of fun. Yeah. Finn just did like such good work that I couldn't possibly say no. I think the drone PR is still probably the cleanest, like the cleanest non-trivial code I've received. Super fast, worked super well, kept working on it. You know, have like several little projects now spinning out of this. It's either already or shortly will be on the drone. Mm, mm, mm. Code is basically based on it. See, there you go. Help my boy Finn out here and give one of his drone things a repost once in a while, eh? He's doing really cool work. Undergrad writes better code than basically any of the MIT PhDs I know. And the math for that stuff is a total pain in the ass as well. Pixel only drone, PhDs write papers, not code. Yeah, that's why science is such a mess. Because the experiments still require code, and if you're bad at writing the code, then the experiments end up being wrong half the time. Oops. Let's see what you've got. That is a solid little renderer that you have there. Yeah, that is solid. If I wanted like a really dumb hack, I'd add one extra channel with edge detection on this just to see. But you probably don't need it. This is awesome. Yeah, the 64 by 64 is like surprisingly more than enough. 32 by 32 might be a little rough, but honestly, you could maybe even get away with it. Very nice. Works with four. It works with 4 pixels. What? Are you serious? Wait, it works with 4 pixels. 4 by 4 pixels, 16 pixels. That seems sketchy. Alright, that seems sketchy. Does it have any other obs or something? You told me 16 by 16 or 8 by 8, like maybe, but that's ridiculous. Alright, but if it works with 4, like that should be able to run millions of steps per second, no? Damn. It would still be hard for us to do pixels everything, right? Even if we could get these speeds. You know, actually, so I did something really cool for the NYU people over the weekend. So they have all these point encoders, right, where their obs are basically like a bunch of points, right? So they have to do the same little neural net op to the same points, and then they do a max operation. So I wrote a custom kernel for that, and it turns out you can make that just as fast or faster than a standard linear layer would have been, like with a concat. But it's like 6 times too slow if you do it naively. So that actually might change the way I think about observation representation in the future, but it also might not. Like, there's probably a lot more work that I'd have to do on it and think about it. Each one pixel pointed in a direction. Wait, 4 pixels of 4 cameras. Oh. Oh, so that basically becomes a depth sensor, right then? Yeah, that basically will just become like 4 depth sensors. Huh. Yeah, that I believe. I believe you could navigate off depth. That's cool. Yeah. Fatigue is just terrible. And I don't know. I went for a really hard run this morning as well, so just about tied PB for the 10K on this course. The goal for Puffer 4 is 10 millisteps per second, like across the board pretty much. We're gonna get Puffer to 10 mil. You mark my words. Like, that's what it's gonna take for Puffer to just be permanently the best. And then nobody be crazy enough to do this type of thing. $40.90 or $50.90. We'll see if we can hit it on a $40.90. CPU will only matter if your M's are slow. Though, to be fair, that might have to be with GPU M's. I don't know. That might have to be either GPU M's or a ton of CPU M's. We'll see. I think we have to take Python out of the loop completely, maybe. Got some questions about RLHF. I do not know anything about RLHF. Why fatigue? Just been doing a bunch of different things this week, Jess. Worked a bunch over the weekend as well. I went and I got some I got some creatine, see if that helps. I found a form of it that's supposed to not destroy your stomach, so we'll see how that goes. Italy. I don't know, I'm often pretty fatigued, but then again, I kind of have good reason to be with all the training and shit I do. $20. If I take 20 grams and this thing turns out not to be great on my stomach, then I'm going straight to the hospital based on the first time I tried just standard creatine. So we're not doing that shit. We'll take the normal amount, thank you. Bad reaction to creatine? Oh yeah. It's like horrible, horrible stomach cramps, like in the restroom all night at 4 in the morning. Didn't really try it again after that. That was like a few years ago. You really don't need creatine. I'm not massive now. This is the lightest I've been in a while. I'm just really lean. Like I weigh 168 right now. My heaviest was 190. I'm almost as strong as well. Almost as strong. Except my shoulder strength, but that's an injury. Honestly, I think the creatine's gonna be kind of annoying for running, because it, like, makes you gain a few pounds of water weight, and then you have to carry that shit. Right? Mm-hmm. Why does split return a frickin' tuple? 5'9", Jess. Plum average. How? I should be doing a couple sets as well. I'm just like, I want to get this stupid thing done. And I used a lot of my training energy for the day this morning running. Like anything sub 9 on this course is super high effort. It's a tough course. And it was like 8:38, I think. What is going on with this? Huh? Does it keep the frickin' dimension? Is that what I see? I mean, I can do it the dumb way. Tiny box Pro. That actually might be a good idea. Where is it? Does it have a buy button yet? No. Is it on Twitter? Where is this? Let me see. Where are the frickin' specs, though? Yo, where are the specs? I mean, I could go buy, Though I don't think I want to buy hardware until I do 4.0 and, like, optimize everything. So I can see actual perf on rented machines first. Okay, here they list it. Oh, ho. Yo. What? So I'm assuming that it's not actually 128 cores, right? It's got to be a 64 core chip, 128 threads or something. I mean, I have Discord with him from when I, like, bitched about the tiny box I bought having the power cables not freaking work. But where... Are they actually 256 core machines? Well, I mean, yeah, it was, like, annoying convert, because, like, was he right that I was not debugging these as, like, as well as a technician who just messes with their hardware all day? Yes, but on the other hand, I was debugging shit at least as capably as his average customer, if not better, and the shit was just whack, right? And, like, they shipped 2 refurb boxes, one of which just had loose power cables, and the other which just had a straight up bad power cable, and it took me like over 2 days to actually disassemble the Swiss watch. They'd never actually had to take out GPUs for testing, so they didn't know what a fucking pain in the ass it was. And my unit was also super tight. Um, so, like, yeah. I'm happy with them at the end of the day, though, because, like, ultimately it was just a couple cables and everything else has been great since. So are these like... Damn, this is actually a 128 core chip. Wait, but this is an $11,000 chip. So how the fuck does this work? It's kind of silly they stick a 1 TB drive in here. That's kind of obnoxious, honestly. That's pretty solid, though. That's pretty solid. I will definitely be considering that. What do they look like? This is a dramatically better configuration as well than their like these boxes behind me are they are more of a pain in the ass. This is like way better for maintenance as well. A quick repost. Hack on my 4090s. Pay my little brother to hook it up. Pay someone to build. 4 mil tomorrow. Yeah, I mean, you probably could, but like, what do you do with it, right? GB3. Yeah, I saw that. I don't know what the hell that is about. Can you get access to GB300s like rental somewhere? At some point, I want to benchmark. Probably when I get Puffer 4, I want to benchmark it on everything. You know? People I'm trying to hire are pretty much retired. Yeah. That's kind of how it would go. And my plan for Puffer is basically to, like, keep doing this, guarantee the future of RL, probably make a pretty damn good amount of money in the process that will be enough to be both personally comfortable and also to just, like, do whatever the hell 5 to 10 person scale science labs and various different efforts I want forever. You know, kind of not try to scale, not try to massively scale personnel, but just like do really concentrated efforts on areas that nobody's working at, like things nobody's working on that are important. And then basically just ignore all the noise of everything else. Land in a manufacturing facility? No. Mm-hmm. Well, I mean, I have to still do it, right? Like, growth on Puffer's been pretty decent for me. Basically not trying that hard on the business side. Like, on growth, at least. We obviously try hard on our existing contracts. I think you can force it with engineering. After I make RL like mature stable tech, I'm gonna just go chuck it on a bunch of different areas of like sim dependent research. Well, that's pretty fucking cool. So this runs. This is not getting processed. Oh, actually, that's funny that I just did. I'll let it run for the memes in case it learns, but that's reusing the same cell twice. It actually learns. That's super funny. Like, that's using the same cell twice. Huh. It actually does better as well. Look at that. I literally just stacked the same layer with shared weights on top of itself by mistake, and it does better. That actually does a lot better. That's kind of funny. How's their sweep going? 537 is the best. So we just beat this best sweep result so far by stacking the network on itself twice. Well, we're going to try it a different way. We're going to try two separate layers. Right? You mean like my first paper pretty much does that. My thing, it's like built off of highway nets, which do that. See you, Yassine. Thanks for dropping by. Ooh. This is working pretty nice. Interestingly, not as well as just stacking on itself, though. Hmm. I think it's stuck at 350 now. Can't fully solve, Interesting. What if I do this? What happens? What is the source of income while you work on this project? We have clients. So this is all open source, but companies that have needs for custom simulations like high perf RL, dedicated R&D support. These are all things we offer. Hmm. Okay, so I mean this does better-ish. But we gotta go run another sweep with this one now, I guess. The M's you work with, are these policies supposed to be like high-level planners? Not necessarily. You can do low-level control as well. Like here, this is technically a low-dimensional control problem, but a very, very precise one. You can try to play this thing and you'll just get wrecked. Like the opponent's really good. Some of the stuff is high level, higher level. This is a little bit higher level, but not really that high level. Yeah, it's kind of it varies a bunch. Oh yeah, this is like a planning type env, I suppose. It's still doing control, but it's not like, you know, you'd probably use this mostly for planning stack. Several things. Spencer running stuff. Young's running stuff. We'll leave him alone. This is idle. I'm gonna use this for a bit. This is probably his fork or something. Yeah, we'll leave him alone then, I guess. I guess we'll just do, yeah, we'll just do tiny. I always forget you can't do ghost. So annoying. Launch a new sweep. And see how this goes. Hey Joseph, why are you working in a barn? The correct question is, why am I working in a warehouse? And the answer is, because it's awesome. I've got GPUs and gym equipment. All I want. Nice warehouse. Epoxy floor. There is epoxy on part of the floor, but then there's also, we've got 3/4 inch rubber matting on the whole gym area. You can kind of see. Let's see. There we go. There's the whole setup, pretty much. Speaking of which, I think this is stable, so I can probably go do a couple sets. It even has overhangs. Those windows? Wait, what? Where can you see my windows? Heh. 3-phase. Here are all the boxes. Oh. Live in a house like a bozo, dream of owning a warehouse. I should be living in it. Oh. Warehouse setup is good. Let me see. I'm tempted to try my deadlift for the day. I think I should hold off though. I kind of did something weird with my knee earlier. A couple light sets in while I'm waiting for a few sweeps to run. Do grow. Depends on the year. This year was corn. Okay. I mean, this is progress. It does seem not quite as good with the one-layer version. So I guess we'll find out if it's like a layers problem or what. So you'd expect to have some good runs by now. Let's spend some time looking at the paper to see if I've messed anything up. How do you power? Do you have to register as a company for the... well, there is a company, but no, you don't have to register as a company. These things draw like 10 kilowatts. We have capacity for 50, and like farm equipment can use way more than that. This is not like a giant cluster. This is pretty minimal. You know? The only thing that bothers me about these is they sent me cheapo fans, and some of the fans rattle, and I just don't want to take the 4 hours I know it's going to take me to, like, grab the boxes with the rattly fans, like, put them on a work table, open them up, replace the fans. Annoying as hell. Have an intern do it. Ah. It's okay. Okay, so... yeah, we want to check the min group paper, right? See, this is the problem with these types of papers, is their experiments just suck, right? Let's see if we can figure out anything about this, though. Mamba have state, or is it... no, Mamba's like linear attention method, right? So they get that the GRU is better. A little bit. they get min LSTM. It's very unstable. Okay. Well, this is at least stable, but it looks to me like the one layer variant is worse. Oh, you know what? I think that I have... Let me see if I can just match the LSTM width real quick. Because I don't think I'm doing this correctly, right? Dim inner. So shouldn't this give me the same setup? No. Because the hidden dim needs to be the same, right? Try one thing real quick. Hmm. You really wouldn't expect a huge shift in hypers, would you? Oh, there's no bias. Interesting. $12. 463. How are ablations going? 99 items. Okay, 842. So we're starting to get to like maybe this can actually solve, right? This one's having a hard time of life. This is getting to like, maybe we can solve the task. Worth investing a little time. The orthogonalized init actually helped a lot, it looks like. It could just be like jank. Now let me see if we can figure out why the param counts are so different, right? Let me see if we can figure this out, right? Of course it'll be puffer constellation on everything. But there's a little more to do before then. In features. Okay, so I think it has 2 blocks of this, right? So it's 512 by 128. But the LSTM has 2 such blocks. Anything you set up on 1B besides defaults? Yeah, I typically will set up points like, I'll set up plots like this, where I have parameter, and then I have score, so I can get like stable ranges and stuff. I also do like sweep progress, so I can see over time, am I getting better and better runs or not? And I do quite a bit of stuff. Good time to mention to folks, if you're new around here, you can support my work for absolutely free just by starring the repository. It actually helps way more than you'd ever expect. Right here. And we are currently at 4090 stars. 4090 stars. That is awesome. That was really cool. Just chugging on through here. It's funny. It's a cool little game. I actually really like the graphics in this thing here. Is this like billboard sprites? Yeah, it is, right? I think what I would even ask him. I think it's just the texture on it. This is just really well done. No, we don't. We don't have any RTS stuff. The action spaces are pretty tricky. You'd have to think about them. Right, so I was trying to match the dimensions of the LSTM as best as I could. Let me go take a little bit more of a look at our Mingru. So for this case, this is the easiest one, right? So it's just you do G, wait, hidden gate. I don't understand this actually. Where are the default config values of Puffer stored? I can't seem to find them in the repo. They're there. There you go. PufferLib, config. There's a default file in here, and then there are overrides for all the different M's. And then you mentioned there were styles of code that were good, but you could personally never work with. What do you look for in terms of how people structure their code? Minimal abstraction. Write the thing top to bottom in the damn simplest way possible. That's pretty much it. No, like, OOP dogmas. No, like, I must modularize and future-proof the crap out of everything. No, every single, like, file must have a billion lines of test coverage. A couple tests are fine. Just like people who really value simplicity. Speed and simplicity. If you look at Neural MMO, it's one of the most complex RL environments out there, and like a freshman undergrad can read it, like just top to bottom. There's like a couple things I think with the terrain shader and like a couple of the rendering tricks that are complicated, but everything else is just dead simple. It runs 1.5 million steps per second per core. It's speedy. All right, what is this G? So 2 gate and hidden. Okay, what is this chunk? Actually, what the hell is this? Wait, so G. What the hell is... Oh, this is G. Just an activation. Okay. It's just an activation. So you do this. dim inner times 2. So would it be expansion factor 4 then? I think it's 4, right? Okay. Now this is bigger than the LSTM. Because it has a projection in it, right? Okay, so this might not be what we want either. But it's worth running it just to see. Really not amazing, though. Nope, there's one good run. Yeah, this is not the same thing, though, right? Because... Yeah, this expansion factor is not the same thing. It's, like, kind of interesting, but... Like, the LSTM really has 4 separate gates. Yeah. I think what's the best set of experiments to look at? Does anybody have anything else with Mingru? These are just from the paper. No original work. The heck is this? Abandoned little library. Ascend high processors. I used to use that name. Dang it. I think Kyung posted full sweeps of this exact environment right at Breakout before. Hard to say. Yeah, we're getting these perfs. We should definitely be able to get some solves. If this is not just a bad architecture. It's like pretty close. I guess we can keep it going. It could just be different hypers. It's possible. And then this one just takes a while, I suppose. Do I want to try min LSTM as well? Let's understand this one first. So HT is output times tan H. Output is a linear projection of these. X HT minus 1. CT is like this. I'm gonna try to really understand this. This is not remotely true either. Okay. T is a linear of xt. Does it make sense that this thing even works? Like, the weird algorithm. Oh, okay. I think if we should be able to get something with this. I mean, there are two distinct possibilities in my mind here, right? So one is that, like, fundamentally, there's a weaker recurrence relationship, and you just can't get anything as good out of this. The other would be that you need to just stack it. Like, you need 2 layers at least, because the the nonlinearities are weaker. This was rejected. The fuck? Let's see what this is. I want to read this. Okay, so I get this at the very least. Gated recurrent. We know it originates from this. I want to see if this has comparisons to the original. This is very low quality work. The experiments at least are very low quality work. Where's the open review? Oh, cool, MIT. Okay. Token mixer. Yeah, this is useless. Yeah, this is useless. It's got embedded layer norm and all sorts of shit. Far too complicated. I guess this module, though, HRU, we could use this. Let me see if they have any experiments. They're useful. Dude, I don't know what the fuck is wrong with people. Like, nobody has the baseline that you'd obviously want. Okay, let me see if I can find... Let me just look at this real quick. So this is... Thing. The layer norm. Where's the, like, LSTM? The forget gate and the output activation are the most critical components. Says. I remember this paper. And let's see. Oh. Well, this is an asshole comment. It's like a completely different paper as well. Something like this, though. Okay. If this is a ref. The hell is this bastard? Like the most douchebag comment I've ever seen on a paper. Holy fuck. I got very few, but a handful of timeouts. I set max moves insanely high. Huh. Weird. This has like layer norm and linear shit in it. Like, fuck. Yeah. You need the forget gate. Cool. Oh, this is not tuned though. Keep reading this. Jess, I'm reading through basically Mingru and all the related stuff, and I've never seen this before. So, the author of another similar paper, who's not a reviewer on this paper, just like being a total douche on the open review. Like, it's kind of sad. I think that this contributed to this paper getting rejected, and this is like a dramatically better written paper than this imbecile. Like, okay, they were able to run bigger experiments and they have a fancier model, but like this paper is actually way better at presenting these ideas. Yeah. It's like annoying as well because yeah, this other paper um has better experiments, but yeah, congratulations, you had more compute, and it's like a much more complex architecture, and it doesn't do anywhere near as good idea of like presenting the main point. And they all have the same issue, right? Where like they don't actually compare to the original LSTM or GRU as far as I've seen, which is like the one obvious fucking experiment you would want. They don't have, but like none of them have it. They actually went and they did the experiments as well. Okay, yeah, that's good. Cool. Okay, so this is true. Um, Still a good paper though. Experiments could have been better. Want to see if they have. The hell? This is why you don't work in academia. It's like such a shit show. Okay, well, let's go take a look at our current sweep, and then we'll go look at the other stuff. So we are starting to get some decent runs. This is a full solve right here. And full solve in 95 mil as well. Oh, yeah, that should be fine. And this one, much slower, so this is gonna be a while. Okay, let's go take a look at this. Complex valued recurrence. Forget gates with monotonically increased lower bound values. They don't have small results. Or RL. Yeah, so this one is actually kind of useless, I think, to me. Adding complex values. Ugh. About this one? Maybe this one gets saved by appendices? Oh, lovely. Look at this. The fuck? Let me see if there's anything usable. Do they even have code for this thing? They do have code for this thing. Okay, that redeems this a little bit. Let's see how this looks in comparison. You gotta be shitting me. They put they put this script that doesn't actually have the frickin' bruh. You put this here and then you're criticizing the other paper that's actually good? Fuck off. Let's see if this is anything good. This has sigmoid tanh, but that's for LSTM. Where's GRU? Linear, sigmoid, and some dots. Okay. So this really doesn't have many activations on it. The LSTM might be a little better though. D tanh of linear of X. I is this. And this. Drop range restriction. So instead of doing tanh, goes to linear. Output is time scale independent. Oh, so this one actually... Okay, cool. So, two. Just two gates. They don't have any tanh. And this one is sigmoid silu. Very similar, right? And they put layer norm on the output in linear. They don't think changes it at all, right? But I'm a little sketched with their LSTM formulation because the GRU one seems to be... I don't know if this is a good adaptation, right? If they do worse with LSTM. LSTM should be better. Training runtime. Let me see what other charts they have in here. If I can get this to work, this will be very nice. Like, this is a dramatically better paper as well. Right now, I just wish all of these, like, none of them bother to compare to the original model, which is so obnoxious. Right? Like, it's the most obvious thing you'd want. Like, why are you comparing this shit to transformers and stuff? Like, if you just make a better recurrent cell, like, you realize we still use recurrent cells for stuff, right? Yeah, so this says, looks like they needed 2 layers to make this thing work. Yeah, so They have this architecture here. We'll probably grab this setup from them. State space. They had to do this shit on P100s? Ugh. And T4s. That's brutal. Yeah. Embedding dimension of 128. 3 layers. Yeah, but this is like such a different setup, right? Hmm. Okay, I mean, this is like... We are getting stuff to solve, I guess. We get the Pareto. Yeah. 50 seconds. And I haven't optimized this thing yet either, really. Because this can go way faster, right? And presumably, yeah, this has to be able to train way faster. That's another thing to look at. The actual speed diffs. I think this doesn't do as well. This takes super long. No, it doesn't look like it takes super long. Let me go take a look at the... Let me see. This paper has Mamba. Trust those tasks, though. This is 2024. Would you say OS and networking is relevant for the work you do? No, not really. Basic systems dev is, though. Basic systems dev is very important. This looks way harder to make fast, right? Hmm. Okay. I mean, use linear variants then are pretty much what we have. We could try this. Does have more activation to it. Yeah, it's a little just... It's a little sketchy. You know what? Can we do... Let me play with a couple little things, right? Just play with a couple things. Hello, Naughty Lawn. Welcome. And play with a couple things. Because, like, I kind of suspect that this thing is just lacking non-linearities. Right? Like, the LSTM actually has a pretty nice set of non-linearities that makes it pretty representative. So, like, 100. What's the pros with using Docker during dev? You get the same dev environment every time. And if you break something, it's instantaneous to spin up a new environment. Pretty much the only annoying bit of it is like GPU disconnecting and other small Docker bugs. But I generally find it pretty nice. Okay, we'll see. Is this significant? This is 600 score, right? So just with the defaults, 44 seconds. This was 600 score. We'll see what this is here. Do you know of any hierarchical policies I should read up on? No, we don't really have any of that at the moment. The only thing that's kind of worth looking at is like the fast, slow RNN stuff, maybe. Okay, so actually it looks like adding, just giving it one extra layer here helps quite a bit, right? How do they work? They don't really work for the most part. Is your answer. Whoops. We'll answer that. Wait, what? That's a shame. I had a shower thought. The search is different. Search trees is different from hierarchical. There's quite a bit of variance here. The biggest advantage. I think I'm about the same amount of productive Ronaldo because I don't distract myself like I do normally, but then I spend time answering chat. And then we get all sorts of people interested in the project. And it helps with all the promotion, it helps getting contributions. It's just generally a good thing. Prevents me from losing the ability to speak in complete sentences from just grinding research solo for months on end as well. That's a real thing that can happen, as it turns out. Not bad. And we're getting solves, right? It does seem a bit less powerful, though. Oh. Lol. Okay, so this is more params. But this solves. Does this solve consistently? So I just use the same defaults and this solves. Kyung. Hey, Kyung. So this is cool. I'm using your new sweeps code. Do you have Do you have like a sweep on breakout? I want to see the first like 200 experiments because what I'm doing right now is I'm looking at min GRU. So I'm trying to get us a faster recurrent cell basically. And I'm running some experiments for that. And it's a little tricky, and it seems to me like the base architecture is a little weaker than a standard LSTM, but I want to confirm. Yeah, I kind of need like sweep progress over num experiments type thing, you know? There's a lot of run-to-run variants on these. Tension is quadratic, yeah. Yeah, it is. I need to remember to give myself a reminder for my meeting. Param matching this is kind of tricky. It would seem to me that the correct thing to do would be to do some layers 2 like this. You just to be certain. You can't just do this, right? I don't think this works, but right. Well, with tag break 6. Group tag. Did I do this wrong, Kyung? Gotcha. I didn't see the filter. Dude, what is wrong with this UI? Break 6. Nobody can write code anymore that is not slow. Lag, 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 lag. You're not even doing any operations. Come on. Okay. Presumably the axes are messed up. How do I set this thing, like, grouping merges everything? Oh. I see. Shitty interface. Time created. Okay, so you have lots of solves here. Do you have like the sweep over time or whatever it is? Like how these? Can I just like mess with this? So wait, uptime. The created timestamp. What is up with the this like weird axis bullshit? What is this? That's just so incredibly dumb. Like, write software that doesn't suck, please. Yeah, but Kyung, I like breakout is the really fast, quick check. I have the most amount of like, I have the most general experiments on that. Okay, well this is super obnoxious that I can't check. I'm pretty sure this thing is worse though. So we've got this one, and then we've got, was it this one? Yeah, so we get 50-second solve, I think is our best. I guess I can just go back to, hang on. It created time step. What was it before? It was like runtime. Okay, so this shows uptime. And was my chart uptime as well? Yeah, I have uptime. Okay, so this should be pretty close. You're on 4090, so you should be even a little better off. I mean, I should be better off, but then yeah. The thing that bothers me is like you just have so many runs here. You just have so many runs here that are solving. Like above 0.9 perf. Yeah, it's probably like a quarter of the runs or whatever. And then if I look at mine, nowhere near as good. Should be faster hardware as well. 0.9 would be like this range. Hmm. Hmm. Try index, though it's backwards. I mean, I kind of got the information I needed from that, which is that, yeah, yours is still a little better. Right? And how fast is this thing anyways? I mean, this is decently fast, to be fair. Oh, wait, we didn't get the profile fix. Yeah, I don't know why this is in here, but for whatever reason, these two lines commented screws up our profile. Default plus LSTM. Oh, this actually has a bunch of time on learning still. Shouldn't this be super fast, or does it need a kernel? Eisen associative. The cumulative sum is I mean, it's just a bunch of ops, right, that aren't getting fused, most likely. It probably plays well with compile, you'd imagine, right? This torch got Mu on. 2.9. Kind of want to try this. Yeah, we can just update and install. Okay, we do get something out of compile here, and learn is down to 20% time. So, yeah, realistically, we can get this to be much faster, I think. That's 3 mil. Alright, we're gonna keep trying some stuff then. This is quite good progress. So I think we're gonna try to get PyTorch's Mu on. That'll just make things easier on us. The PyTorch's Mu on. A few other things. Let me get a couple sets in. Let me use a restroom. I'll be back in a few. And yeah, this is definitely worth at least investigating like more deeply. Yeah, we can definitely like side by side these. All right, I'll be right back. Okay. So, oh, you dummy. Let's try this. Heh. Welcome, Jess. Mm. Alright, well, let's see what we got from our sweeps, right? This one is finished fully. Okay, we get some reasonable thing out of this. Okay, so we can run. So what we can do here, right, can be this. One extra yellow. Back over there. And this one is super slow. Doesn't seem to be amazing. 50 runs. Yeah, so this does not seem to be amazing. Like, too narrow, I guess. This makes the model way bigger. You really shouldn't need the 256s. Okay, well, while this is running, let's do something. Does seem effective. Immediately. Okay. And now the main thing. It doesn't have. Why does it not have the same betas? Will you consider yourself cracked? I mean, it's kind of cringe, but yeah, I'm good at what I do. It mostly feels like I do relatively simple things that are somehow just absent everywhere, though every so often I do something that's genuinely pretty hard. Huh. Cool. It looks very good. I love your indie devs. Pretty awesome. They just do cool stuff. I see. Okay. Just go ask. Where's them? Okay. Yeah, that sucks. That's ridiculous. Heh. That's pretty funny. This is totally true. Hey, convert. Yep. Recursion, parsing through equations. Yeah, I always just find it easier to convert it to a loop, man. Like, recursion's just a stack. You can do the stack yourself and then not debug shit horribly. It's so much easier. I mean, if this doesn't work, I'll just do it myself, but I just don't like API's obnoxious. How are experiments going? Not great yet. And kinda moderately okay, I guess. More runs. Dude, what the fuck? Alright, we're closing Grok. Stupid thing. Good. It's this. What? Hang on. Thing. Thought I'd done this already, but apparently not. There we go. Cool, this is what I wanted. Yay. During the Ray Summit is what? Well, I mean, the other one they serve is freaking Llama 70 Bill. You know? So, like, no thank you. Can't optimize on leaf tensor, really? Not checking for requires grad. The heck? I don't know what this is. I I'm not doing that. The heck does it say? Okay, so don't inherit and then just do the steps manually. We can do that, that's easier. Yeah, this is fine, right? Zero grad. Add like a couple of these. Uh, this is so obnoxious. How do they not have this somewhere? Super obnoxious. The hell? Oh, this is just disgustingly bad, right? Thing. Okay. Super obnoxious, isn't it? Cool. Form's way worse though, because we don't have the other optimizer. Hmm. Not super easy, right? Annoyingly enough. Okay. I can just go grab my code for this. Like here. And great, it doesn't work as well as heavy ball. Your weight decay. Epsilon. Okay. That's a lot better, right? We can take this out. I mean, so we have this. 3.5 mil steps, 3.6. Yeah, so that's pretty good. And we will see on the latest the speed with Lucas's implementation. I think that'll be pretty cool, right? Pretty funny. It's about the same speed. Nothing super noticeable. Maybe slight edge to torch. It's hard to say. A hell of a lot less annoying, I can say that. Oh, that's bad though. Okay, interesting. So our new one is just as good then, if not better. New one is just as good, if not better. Okay, so let's just, I mean, we can merge in a few things by now, right? Yeah, not amazing. Not amazing. Okay. Well, let's just merge this. So we'll do Muon into, the Mingru. The hell is this? Oh. Okay, so Torch did some changes, it looks like. We'll just do Muon. Through. Is there a place where you can see research failed? Terrible, they publish. So if you have an idea, but someone tried it and it's terrible, they publish it. So negative results generally are good. The problem with negative results is you have to demonstrate a very high bar of execution so that you can be fairly certain, right, that there is some fundamental reason it doesn't work, and it's not just that you implemented it wrong. Okay. Okay, so I'm fairly convinced that we should not be requiring 256 hidden dimension for breakout, right? Unless, let me make sure. I believe the PufferLib baseline. Breakout. Yeah, so it's 128 here. It's 8. So this is the config. And then the even smaller config. And this is slower. It's annoying. But then this isn't really fair, right? The real test would be like... Okay, so now this is like... this is much more reasonable. But this model is tiny. I don't like the idea that you have to go up to 256 hidden dimension just because of this. Then not find any papers. What do you mean HRL using quad trees? No, hierarchical RL is like the architecture itself is hierarchical. Right? Quad tree CNNs. What do you mean quad tree? Like CNNs do that by default. That's how they work. Like it's by combining like filters over larger and larger receptive regions. It's not exactly quad tree, but like the idea is similar enough. Okay, I mean this is very close to parameter match though, is the thing. Okay. This is interesting. M's. 1024 M's. Spec 8. 32 horizon. Gives me a much more reasonable value for Lambda. About the same. That's totally flipped. If flipped coef. I don't like this 0.1. This is just no clipping. I copied this wrong. This does not seem very good at all. Not seem good at all. Why is this not learning massively faster, I guess? Yeah, this gives you 3.3. Give you. Even faster, of course. Okay, so that's a nice speed up. So, I mean, that's like the overhead of doing this in Python. That's fine. Okay, so now we actually have this at comparable speed to before. I'd like to know why it isn't faster. Oops. Ticked. Okay, something broken with saving. No big deal. Try the min LSTM, I suppose. That might be nice. Go figure out this bug real quick. I'm gonna have to get dinner pretty soon because I got a 7 p.m. meeting later for client. Okay. Favorite food? I don't know, man. I like plenty of food. Meat. Multi-agent soccer right now? Really? We have a similar project planned very, very soon, man. Lots of self-play work going on right now. Good World demo. Oh, that's you, yeah. There's a little bit of a learning curve, but it gets easier and faster every version, with lots of good educational material as well if you're new. Stupid torch compile. If this works. Making it harder than it needs to be. That's usually how it goes. About 20% of your time reading resources, 80% building is about right. And 25 if you're really new. The RL guide that I posted should be very helpful for that, though. I mean, it really does try to take you through a lot in not much time. Okay, so now we're getting, like, somewhere, sort of, I think. Let's just... Love the outfit for it. The outfit? What outfit? The guide is, The guide is just this thing. Oh, the iceberg? Yeah, that one's also... That's a fun watch. That gives you a high-level overview. The real content for learning, and, like, following along is the opinionated guide, though. I'm happy if you watched the iceberg video as well. I put a lot of time into it, and not many people watched it. Okay, so I mean we do have like several of these, no? More expensive ones. They'll get way faster though. Way more steps. I'm not a huge fan of that though. I'm really not a huge fan of that. We not get like steps. Sure thing, well. Stupid UI, man. I can't wait to just stop using this garbage. Okay, so yeah, they all have so obnoxious, man. Well, we could also attribute this to this. You should be able to get something out of this, I would think. Okay. Got this. Oops. Update torch. Let's see if this is any good. I guess we should consider it pretty good that it's the same speed as NVIDIA's optimized kernel without having like anything done for it so far. So we will run this. This will be way faster. And we can see from this what we think of MinGrew. Try MinLSTM next. That doesn't work. There are a few different variants we can try. Grok, go find this. The hell? I mean, that's cool, but why the hell would you ever do type? That's horrible. Like, why would you ever do it that way? Okay, so we will figure this one out. I want to just look at a couple last things so we have a plan. We could try this one, right? But this should not do worse. Okay. Needs 2 layers. Well, we can always do the perf comparisons to this thing, right? Yeah, I don't think anybody's done proper ablations. I mean, I guess I would suspect that you need to stack it a little, no? Like, how would you not need to stack it a little bit? Is it non-linear even in the previous state? That's so weird. I mean, I guess it is non-linear in the previous state, isn't it? Okay. I think we gotta mess around with a couple different versions of this. See? Do linear, you do linear, and you do this. Interesting. I mean, there's like multiple of these I can try. Yeah, there are multiple of these I can just try. I mean, they are testing these versus stronger baselines in a sense, but... Worse, I'm seeing worse perf. Decent, but worse perf. Hey, Matt. Pretty weird. Okay, here it is with clipping. And we'll see if this does anything, I suppose. Will I get dinner? Okay. Well, I'm gonna go get some food. I might do a late night stream. It depends how long my meeting after dinner goes. I might just do like an extra hour, we'll see, to like look at these results. I really do hope this works because I think we can make this much faster. But we can't really give up the power of the LSTM cell. And we want a stronger model, not a weaker model, so we'll see how that goes. In any event, thank you, folks. If you're interested in my work generally, it's all on puffer.ai. Start the GitHub, it's free, it helps me out. You can get involved on the Discord. You can follow me on X for all my educational and research content as well.